Today we're lucky enough to have Donald Clark here at Deakin Prime, so we're going to go right into it. Donald, thank you for joining us today. Firstly, I wanted to get your take on the role of virtual reality in learning and performance solutions these days.
Okay, well, it's not going to take over the world. There are plenty of other solutions, but it has a key role to play, I think, in attitudinal training and learning by doing and taking learning back to what it should have been in the first place, which is less abstract, more grounded. So in terms of learning principles, the really important thing here is it gives you absolute 100% attention. It gives you the opportunity to do things. You can actually manipulate things in 3D spaces, do soft skills training, lots of things in healthcare, which I think will be a big sector. You get the emotional impact of being there. You get contextual less reinforcement of the learning, which we know from research matters. You get the transfer of those skills from that simulated environment to the real world. And all of those things add up to increased recall and retention. And that's the game we're in. So to ignore virtual reality is to ignore one of the most powerful. Remember, the world is 3D. People work in 3D. They don't work in 2D. So we've only had 2D technology in training, like video, flat screens, e-learning, television, film, because we haven't had the tech. Now the tech is here. Consumer tech, remember? That's what will make this fly. You can now buy this in a hardware store for a few $100. That's what's going to change things.
And you've sort of touched on this point already, but when you look at a consideration between, for example, office-based training, and you're considering scenario-based learning, and you're looking at a video solution, first-person shoot with a scenario in an office environment, as opposed to going with a VR solution, can you explain to me why you would be leaning towards the VR side?
Well, one of the things about VR that people forget is it's actually quite straightforward in production terms. There are things like Spitfire from Adobe and tools that, in other words, most of the work's done for you. What you have to do is create a 3D model. So we're sitting here in a nice little environment here. It would take a day or so to build this in 3D using 3D Studio. Like a lot of 16-year-olds could do this for a couple of $100. Once you've got your 3D world, you can then just do loads of scenario training in that one environment. So once you built a ward in a hospital, or a GP surgery, once you've built a little office, anything, or a little area in a factory, you can just then start doing loads of scenario training using the same model. The cost is really in the design of the training and the scenario-based stuff, but the tools are pretty good. And you can skew them out onto the different VR platforms at the top with relative ease as well. So it's not as technically challenging as you might imagine, I think, compared to even video production, to be honest, or certainly console games type work or whatever. But you asked what would be the criteria for choosing one over the other. And I think what VR gives you is realism and authenticity. We know that compliance training doesn't work because it's a bit half-baked, flat, multiple choice based, not scenario based. I think we have a chance of making a real sort of quantum leap, but it's a gear change in terms of the delivery of compliance training, attitudinal training, things that need emotional heart as opposed to answering a few questions about the laws around money laundering from multiple choice questions, which never worked in the first place.
And I'm interested that when you talk about these topics, you tend to focus a lot on virtual reality, but poor augmented reality doesn't get as much showing from you, from what I've seen.
Yeah, well, and that's only because in consumer terms, and there are different forms of augmented reality. I think that I'm not actually such a big fan of some of the HoloLens stuff and so on because it's really a Victorian parlour trick. It's Pepper's Ghost, really, imposing things upon. But they work for some applications, especially technical, stripping down an engine, and maintenance jobs. I can see.
So more tool-based?
Yeah, that's right. However, Magic Leap solves a major problem in AR, which is coping with depth of field, so that when I'm looking around, my focus changes from long to short to medium immediately and unconsciously. The Magic Leap system, because it will come through your glasses or whatever, straight onto your retina, solves that perceptual problem. And they've just raised 743 million, valued at 4.5 billion. This is going to be good. And so I think wait and see would be my view in AR. But VR is already here. You can go online and buy an Oculus today. You can download a bit of cardboard, do Google Cardboard, and put a reasonably good phone in and get a VR experience for next to nothing.
And do you see much lessening of the impact by using something like cardboard as opposed to an Oculus Rift?
No, I think actually the mobile market will probably drive this for a while. There are differentials. For example, on Oculus, for example, you have 3D sound.
Yep.
So the sound problem's a problem with your mobile. You need to get a headphone lead out. And of course, the 3D sound is a significant advantage because the real world is 3D sound. I'm hearing people behind me now, you're sitting here. And in games and simulations, that adds a lot to the experience. So there are several significant advantages to the complete immersion of a VR mask. Getting rid of the tether is another important thing as well. Once it will evolve. Remember, this is like mobile phones when they used to be big and chunky. It's embryonic. And $400 or $500. When it gets below $100 and it's universal and it's cheap and there's loads of free downloadable stuff, which there already is in education, then the thing will fly.
And obviously you've been around a lot and you've been really at the forefront of leading technology change in learning and development for a long time. How do you see this as different or similar to other technology shifts that have happened? For example, the rise of e-learning, that first wave, if you like.
Well, I'm old enough to, when I was at university and school, there were no computers, none, no internet. So I've lived through the birth. We used the very first PCs and Apple IIs using computer-based learning. That's what I was there right at the beginning. And that was revolutionary. Then the internet came along, and that was really revolutionary because that's changed us as a species almost. And it's very rarely that I'm a bit skeptical sometimes about tech being used everywhere and peppered around the place. Sometimes you experience something and you go, that's the future. It happened with the internet. Who could deny that the internet was as significant as the invention of printing and writing? Beyond that, when you put this thing on, you have that feeling. This is going to be a game changer, to use a rather cliched term, because it will change the games world, but it will also change our lives. But I think there's a bigger one, and that's AI. I think AI has far more significance than VR. They're all two letters. But artificial intelligence is deeper, broader, and has more future reach because it just gets better and better and better and better, and will have a much more profound influence on the learning game and in other areas of online activity.
I was about to go there. So when you talk about AI and people think, oh, that's something distant, can you explain some examples of how people's lives are touched by AI at the moment? Yeah,
but because AI is a bit like an iceberg, all the work is done beneath the surface. You don't see it. It seems invisible, but it's not. It's an invisible hand. Every time you go online, every time you use a file, there's a sophisticated set of algorithms that are compressing and decompressing stuff and sending data around the world. It's been here forever and a day. What's different now is that very specific tailored algorithms are deciding what you do and see. So we know that 1.5 to 2 billion people are on Facebook, but their timelines are driven by AI. It's an algorithm that delivers that. We know that almost everybody who has a computer uses Google. That is nothing but AI. Nothing but a set of algorithms. We know that online dating is driven by it, sports driven by it, Netflix, as I say, Amazon, almost every major global service that you experience has the invisible hand of AI beneath it. And that's why you're already enmeshed in an AI world. Everything of significance that's happening online has that component. And there's a good reason for that. It works.
Now, my impression is, or my experience has been with learning and development, that we tend to be about 2 years behind technology in the broader community, like if you look at digital agencies compared to often e-learning companies. Is that your experience with AI in learning and development as well?
Yeah, well, it depends what you mean. But amongst learners, no, because if you take the example of Google, like everybody's been using Google for what seems like ever. Like almost every kid in the school I talked at yesterday was born after the year 2000. They've never known a world without Google. They use it all the time, and it's nothing but AI. So amongst learners, it's universal. Amongst learning providers, it's quite rare. And what we have to do is get out of the 30-year paradigm we've been in, which is the linear series of text graphics, multiple choice question stuff, driven by the tools and quite poor authoring languages, to be honest, which mimic PowerPoint almost. We have to get in and making them adaptive. And you can do this quite simply. You can have remedial, some of those tools are quite good on remedial looping. Get things wrong, you take them back. That's just conditional statements. The next level up is rule bases, so you can trundle people through those. That gets more sophisticated. But the really interesting stuff is the stuff that really is algorithmic. In other words, you're building learning theory into the algorithms. So to illustrate this by example, on spaced practice, we know that spaced practice works. And the research is clear on this, but we haven't been able to deliver it because we haven't been able to get to our learners. But they all have mobile phones now. We have an umbilical cord right in their pocket. And space practice is actually determined by clever algorithms. You can personalize the space practice. If I know when you, Aaron, are going to sit an exam, have a product launch, get a new job, from time now to that time, I can cleverly deliver learning and reinforce learning. The things you were sort of half knew, I would reinforce more than the things you knew. The things you didn't know, I would reinforce even more. You can pattern and determine that pattern of space practice using smart AI to make it that much more powerful. And it's really quite easy to do. There are tools you can buy off the shelf to do that.
Okay. And what about the other side of that, for example, particularly in more traditional models where they're still doing exams and the testing? You talked about the multiple choice quizzes. Yeah. How does AI play in that domain?
Well, I think one of the things that's really clear from the research more recently in cognitive science, and I highly recommend this book, Making It Stick, by Roediger and McDaniel, because they did a lot of the research, is that effortful learning really matters, pulling things out your memory. That act in itself is a greater reinforcer than the original teaching act. So if I say to you, Aaron, what's the name of the most famous Scottish tennis player? What would the answer be?
No idea.
You've no idea? All right, okay. Right.
You could ask me about a tennis player, I wouldn't
have
no idea.
You know the answer, right? Okay, if I say to you, name a famous physicist.
Yeah. Well, I guess Einstein could be
Einstein, okay. Now you've recalled that name Einstein from your long-term memory. When you pulled that word out, it actually reinforces that fact in your own brain more than the original learning of the word Einstein. And that's true of knowledge in generally. So if we can get people to, if you do light testing, testing is learning, not testing as summative endpoint testing, but formative testing, it's amazingly powerful, but it has to be effortful learning. You have to make people pull things from their mind, which is why writing notes, underlining, highlighting, which students are taught to do, is a waste of time. They should be looking away from the page and recalling the stuff. So I've been building AI tools that do precisely that. They take a document, a video, a PowerPoint, they semantically analyze the text and force the student to actually type in the missing bits, of the text and so on, recalling things from their memory.
So that's Wildfire. Can you tell us a bit about that project?
Yeah, sure. Yeah, well, Wildfire originally was it was a conversation I had with Jimmy Wales of Wikipedia, and it was a tool that grabbed a page of Wikipedia and then turned it into active learning. So it semantically, so meaningfully looked for the things that it thinks the student should learn. So in a healthcare program, that would be maybe dosage of a drug, the name of the drug, how long the drug would be administered for, a couple of side effects. It picks those out, and then it forces you to recall them and type them in. Not only that, if let's say there was a side effect in that drug which was hypertrophy, and you didn't quite know what hypertrophy was, it automatically creates a link to Wikipedia, the Wikipedia page on hypertrophy, and you click on it, and both you go to Wikipedia. Then it creates the e-learning on the Wikipedia, all in real time. So it's an AI semantic engine creating e-learning on the fly in real time. That's how, I think this funnily enough, this bypasses the whole authoring language thing. We may be able to take raw material and create good stuff without charging the earth and taking 6 months. It takes minutes, not months.
So can I just to clarify, the main sort of promise of AI in learning, you've identified the adaptive and personalised approach. You've also identified this idea of forced recall and spaced repetition. Are there any other elements there that really adds value to your learning experience? Yeah,
well, one you hinted at, which is if we turn to full assessment there, you have automated essay marking, of course, and also adaptive delivery of questions so that people can't cheat. You have facial recognition so that people can sit online exams at a distance. You can have proctored exams. So if you do a MOOC, I can actually online do facial recognition. They already do typing recognition, which is an algorithmic approach to recognition.
Where's facial recognition at in the context of exams? Is that actually being used?
Yeah, there are companies delivering that now as we speak in MOOC land, as it were. And it's not only like the typing test that Coursera do determines a short paragraph to see what your unique typing footprint is or fingerprint.
And they use that as an identifier, don't they?
That's right, so that when you do sit the exam, they can match it and make sure it's not somebody else who's doing the typing, as it were. Beyond that, though, a much more powerful technique is to not only just take an image of your picture for digital identification, like your passport, but also to do it in real time. So as you're taking the exam, it's on your face all the time to make sure you're not glancing at cheat notes or to somebody, that you're not misbehaving in some time. And they're even now getting the whole emotive thing, what's going inside your brain from your behavior on your face. There are all sorts of weird things happening there that will bring exams at a distance into play.
And what about the impact? Our discussion so far has been largely focused on knowledge in a way, particularly from that wiki perspective. And given that these complex machines are coming and almost replacing the need for so much knowledge to be carried around our head, how do you see that impacting on the sort of future workers, if you like, the people who have got jobs in the future, in terms of knowledge as opposed to that sort of more collaborative or tacit kind of skills? Do you see an impact happening there?
Well, funny enough, the impact of AI and the literature points towards it decimating not vocational learners, people who do things, the people who collect your rubbish and build your houses and so on, they're going to be relatively unaffected by this in a funny sort of way. But the people who rely on abstract reason, lawyers, accountants, financial consultants, middle managers, we already know that AI can perhaps do many of those tasks better than those people. So there's no reason, the literature is now quite clear that some of those professions will be seriously hit by this. They already have been. The middle classes, middle management has been getting drained away by IT for many, many years. And that will continue. And perhaps the literature suggests that it will accelerate, and that about 47% of those jobs are really under threat. 40% of jobs overall are under threat because AI can do them better, quicker, cheaper, 24/7, scalable. Not many people would disagree that this is now happening.
And you've identified vocational skills as something that will survive the robot apocalypse, but what about things like collaborative skills? And a lot of people point to those sorts of things as coming to the fore as well. Would you agree with that?
I am actually a bit sceptical about the 21st century skills agenda.
Yeah.
It slips off the tongue a little bit like digital divide. It's got a nice feel to it. But when you really dig under the surface and say, well, what are these collaborative skills, Like when teachers say, we need to teach kids collaboration skills. Kids collaborate every 5 minutes on Facebook. They know more. They know 100 times more about collaboration than you'll ever know. So I'm not
they're piloting Minecraft in Queensland schools at the moment to teach collaboration.
Well, I'm quite pleased with that because there's a good example. Minecraft, a very good friend of mine, Chris van der Kuyl, creates. He runs the studio for Minecraft, and that's crept into education quite nicely because I've always been suspicious of Lego being a creative tool. People use the word creative all the time. What's so creative about building a set Star Wars model that cost about $400 from bits of plastic? Try Minecraft, that's creative because you can mod it and you can do all sorts of wonderful things from scratch and your only limit is your imagination. The limit of Lego is the limit of the marketing franchise with Star Wars. And so it doesn't surprise me that Minecraft has crept into that world. Of course, the gaming world has been into AI for a long time. Most of the other avatars in games are AI driven. And so soft skills, we're following in the footsteps of people who have already pioneered this stuff in other contexts.
Well, we're coming to the end of time, and I'm aware that a lot of our audience are people who are in organisations trying to implement agendas around becoming more adept around digital learning. So they're almost having some battles in some cases around e-learning, and then we're talking about these sorts of issues. For people who are feeling a bit maybe overwhelmed or intimidated about these sorts of issues, how do they get a handle on this? Where do they start?
It's a good question, this, because innovation is not innovation unless it's sustainable.
Yeah.
I really do believe that mantra, really. And if you're a business guy, if you don't believe that, you lose a lot of money. So what will make this innovation sustainable is the fact that we're mimicking things that are already hugely successful. There's a reason why Facebook and Microsoft and Apple and Google are the big tech giants. And every single one of them have spent hundreds of millions on AI recently. We'd be fools to ignore that because that stuff will be available like utilities to us. It's like turning on a tap. So it also creates a massive opportunity for small companies to do quite innovative things in the learning space, as opposed to the straightforward bespoke learning, content production, tools, do we need another authoring language that mimics PowerPoint? I don't think so. We have to become more web-like and more like the medium which kids use every day, more like Google, more like Facebook. And AI is in those, so it has to be in our learning because it personalizes learning, the great holy grail. The brain needs to have specific stuff delivered at a certain time and a certain rate, and that's unique to every individual. We've never been able to do that before. And e-learning has just mimicked the classroom, really. We batch people through linear curricula and linear courses. We're going into a non-linear, algorithmic-driven adaptive learning world where things are tailored for the individual. That's what you experience on the web every day. When you type into Google, you get what you need. Every letter you type in, the thing is working ferociously to predict what you, Aaron, want. And in learning, it's even more important, because in learning, if you don't personalize, you get catastrophic failure. And that if you look at a distribution curve of learners, half of them are bored shitless, the other half fail, and you hit some people in the middle. We have some opportunity here, at least coping with all of these people at once.
Well, that's fantastic. There's a lot to take in there, and I really thank you for your time today.
No problem.
Thank you, Donald.